Those are 3 things on your quiz tomorrow. That's Thursday, August what? 26th, okay? So those are your 3 things you got to be ready to play with. Now, here are your notes for today. These will be on test 1 potentially. So here's our little graphic about the scientific method. And now let's go ahead and talk about how to write an experiment. So here's the schedule. Today, we'll take a little bit of notes, and then you will write your experiment. Thursday, you guys will take your graphing quiz, and then maybe work on your experiment a teeny bit more. Over there. And then Friday, you guys will actually carry out this experiment. So today you won't be lighting anything, but on Friday you will be. Really fast. On Friday you will be, okay? So it all starts with a research question, okay? It all starts with a research question. That is what leads to your study. And every part of your project is done to answer that. So everything you're doing today, when you're writing your experiment, should answer your research question in some fashion. Will you put this back on? Oh, look at you, smarty pants. Perfect. Okay. Now, let's talk about your hypothesis, okay? Your hypothesis needs to be based on some sort of prior knowledge or an observation, okay? Your hypothesis does not have to be correct, okay? But it should just be completely random. I think the water will boil at 4,000 degrees Celsius because I like the number 4,000. Okay, that's not a number. I'm sorry, that is a number. That's not a reason. Okay, you have to have some sort of prior knowledge, like, oh, because we know this, or because I wonder if this is what's going to happen, that kind of thing. But you have to have some sort of prior knowledge or observation. Write your hypothesis as a statement. Your hypothesis may be totally wrong, but that's what you'll talk about at the end, okay? So if Laura writes her hypothesis as a statement, when the water boils for 10 minutes, the temperature will blank, okay? She could be totally wrong. Who cares? At the end, she'll say, and my hypothesis was totally wrong because blank, or my hypothesis was totally right because blank, okay? So just write it as a statement, and then you'll talk about whether a statement is actually true or not at the end. Now, your experimental design, okay? There are some things you got to remember, especially about the variables. Okay, so the variables are part of the experiment that you're controlling, okay? Now, your experiment, your trials and all that good stuff, everything should be done exactly the same. That's why we measure everything, except what? You can have only one variable that should change, and that variable is called the independent variable, right? So you want to do everything exactly the same, except you'll make one change on purpose, and that's your independent variable, okay? You'll make one change on purpose. That's why the milk lab was terrible, because we accidentally did a bunch of stuff differently. Did you measure the milk for each trial? Like, well, no, so I might have had 15 milliliters one trial and 18 milliliters the next trial. Oh, I didn't measure how much food coloring I used either, or the temperature, or the, oh crap. And so the reason why the milk lab was bad is because you did many things different between the 2 trials, okay? Whereas you need to measure stuff as much as you can so everything is exactly the same except for the one change you guys made, okay? Except for the one change you guys made. So, now the control that we sometimes refer to as the normal, okay? That's a sample that is the same as the rest, except nothing changes about this group. Sometimes we refer to the control as, that's just what would have happened anyways. That was what would normally occur. If we never did this experiment, this is what would have happened, okay? But the real thing, or the most important part about the control is that it's what you use to compare, okay? Oh, the water was a lot hotter than the control. It heated up a lot faster than the control. You're always comparing back to the control, okay? So it's all about comparison. This is a huge idea. Controls are for comparison, okay? How do you know anything is faster or longer or what, or larger or whatever? How do you know that? It's always larger, faster, whatever, compared to the control. Compared to the control. All right. Now your experimental design, okay? You need to be thinking to yourself, is this repeatable? In other words, here's what I want you to imagine. Imagine that your lab partner is actually absent today, okay? If you write a procedure and you write a materials list today, if they were to just have that list on Friday without your help, could they do the whole lab without you saying a word? Okay. Could they repeat this without you being there? Okay, so that's what you want to think of. So your procedure needs to be a step-by-step, detailed description of how you will conduct your experiment. A little tip for you. I would use numbers. So I would do stuff like number 1, blah, 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 blah. Number 2, blah, 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 blah. Okay? I would just list it out. Makes it easier because then you can be like, repeat step number 3 through 7 or something like that. Like it makes your life easier and it's a little nicer to follow. The material is a list of all supplies and equipment. Don't forget sizes, okay? Sarah, so help me. If you tell me to get a beaker out, I'm going to lose my mind. Be like, which beaker? There are 4 in there. Which one did you want? I don't know. She's like, get out the 250 milliliter beaker. Get out the 100 milliliter graduated cylinder, unless you want to use a 10 milliliter graduated cylinder and measure like 13 times, okay? So just make sure you're really clear. Don't tell me to just pour water in. Tell me to pour in how much water. Don't just tell me get some salt. Tell me how many grams of salt, okay? You have little scales, by the way. You end up using salt. Don't just say, get warm water. Tell me the temperature. Now, as you observe your experiment, you'll need to record its progress. So data collection, okay? Obviously, use your senses to observe them, okay? Now, data will be a couple of flavors. It'll be numbers, quantitative data. 33 degrees Celsius, 22.1 milliliters, some sort of number, 16 minutes. And other times it'll just be quantitative descriptions. The water began to boil. So sometimes you just want to write down, hey, the water started boiling, okay? That's a qualitative description. There's not a number involved with that. Now, data should be in a table somewhere. You will notice in the handout I'm going to give you guys a little bit later, there's a table provided for you for your data, times and temperatures. So always should be in some sort of table, and you don't want to forget your units, okay? Throw some milliliters my way, some degrees Celsius, some minutes, whatever it is, make sure your data table is clear. Label it, label it, label it with those units. Now, after you've done your experiment, you've collected all your data, okay, you're going to start drawing some conclusions. The very first thing you should do is you should answer your research question. Be like, all right, so I asked, what will happen to the temperature of water after it begins to boil? And I found that the temperature of water, blah, 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 and you talk about it, okay? Now, you should decide whether your hypothesis is accepted or rejected, okay? So Gloria needs to say, my hypothesis should be accepted or rejected. And don't just say, because it was not smart. You should say, because, explain why using your data, okay? So, no hypothesis should be accepted or rejected unless you specifically refer to the data. Because at times 2 minutes, 8 minutes, and 10 minutes, the temperature was blank, blank, and blank. And that tells me this, okay? Have numbers, have observations that you are using to back yourself up. Shouldn't be an opinion anymore. It should just simply be like, here's what the data said. Okay, some things to note. Always wear the proper safety equipment. In your materials section, you're going to have to talk about a couple of things. So we're lighting Bunsen burners. So what are the 2 safety things you'll definitely have to have? Hair tie and goggles, right? You need both of those things, okay? So some people might put hair tie in parentheses, if necessary, okay? Not necessary, 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 necessary. Kind of pushing it. Necessary, necessary, necessary. Definitely not necessary. So you want to make sure you include in your materials, your goggles, and your hair ties. Never fill a beaker more than halfway full, okay? You guys will get to choose what size beaker you want to use. But just keep that in mind. You shouldn't be like, let's get 300 milliliters of water. Be like, all right, now grab the 150 milliliter beaker. Please, okay? Want to use your head there? Get fresh water for each trial. That's a big one. Make sure you get fresh water for all your trials, for sure. Never leave the Bunsen burner unattended, okay? So if Sophia needs to ask me a question, Riley better be watching their Bunsen burner if it's lit. If Riley can't do that, she should turn it off. Kill it at the valve for me, okay? Door number 1, right? Want to turn that off? That's how you get your last point on the Bunsen burner part of your test on Tuesday. Turn it off right there. In case of a thermal burn, cold water, lots of cold water, please let me know if it happened. And the boiling point, this is a rolling boil right here, This is a rolling boil, okay? Not just a couple of bubbles every now and then, or like the tiny little ones rising to the surface. Like, we're rolling at this point. So I have an example of this boiling water on my desk. Other things to note, I'll mention those in a minute. Let's talk about the background information, by the way. What is temperature, Mr. P? I'm glad you asked. It is a measurement of the average kinetic energy. And it is a measurement of the average kinetic energy. Average kinetic energy of the particles in a substance. It is a measurement of the average kinetic energy of the particles in a substance. And the boiling point of something, well, that is the temperature at which a liquid turns into a gas. So this water is at its boiling point. So that is the temperature where that liquid water is turning into a gas. Where that liquid water is turning into a gas. Alrighty. Now, we're going to talk about how you're actually going to do this experiment. So we're done with our notes, okay? Now we're going to move on to our handout that you guys are going to use. I saw a little paw back there, I think. Is there a paw over here? Question? Okay, we're all good. Here you go, Keelan. You're going to send those around the horn. So, let's talk about how we're actually going to do science. So, this first investigation you guys will be doing on Friday. So, you're going to write your procedure today. You'll actually do this on Friday, okay? I've done a lot of this for you, at least the very top parts. Here is your research question. I'm telling you this is your research question. What happens to the temperature of a liquid after it has started to boil? So you want to know what the temperature is doing right now. Is it going up? Is it staying the same? Is it going down? Right now, as it's boiling, what's happening? Your hypothesis will be this. When H2O starts to boil, the temperature will because okay? So you got to tell me it's going to go up, it's going to go down, it's going to stay the same because give me some sort of reason. Your reason doesn't have to be correct, okay? You probably don't know. You're like, I don't know if it's going to go up, down, or stay the same. I think it's going to go up because, and give me something, okay? Where we're going to be spending most of our time is going to be right, Sean, with the materials and procedure section, okay? That is where you're going to need most of the rest of the period to get all that sorted out. So here are some things I want to mention about your materials and procedures section, okay? Your materials, you can just use little bullet points, or you can use numbers again if you want. So some people might just be like goggles and, you know, hair ties, blah, blah. But you want to list everything you need, okay? So what exactly is everything I need? Hey, look, Mr. Filter, you're turning it off at door number 1, the gas valve. Look at that. Turn that off. Go ahead and move this because this is nice and cool down here. I'm going to use my what to get that beaker off there? Beaker tongs. Yep. You got it. Yoink. Okay. If you want a beaker down to cool down, if you want a beaker down. If you want to cool a beaker down more quickly, you can plop it right here. If you don't need the water, you can just dump the water out and then let it sit here, and the beaker will cool down even faster if it's empty. Just an FYI. Just so you know. The one thing you definitely can't do is try and cool this beaker down by putting it under cold water. Okay? Don't do that. It will shatter, and I will be upset with you. Mr. Pilcher, what can I assume about the person I'm writing a procedure to? You can assume they are a chem student like yourself that is fairly competent. What that means is, if you say the phrase, set up standard, now you shouldn't abbreviate, I'm going to because I'm going to run out of room, apparatus, you can assume that they are competent and they know how to do that. This is what a standard apparatus is. Ring stand, Bunsen burner, small ring clamp, wire gauze, big ring clamp. That's it. Okay? There's no beaker on there because the size of the beaker depends on what you're doing. Okay? So if you say standard apparatus, then you can assume that they can do this. However, if you are going to use a standard apparatus, which honestly all of you will, then you're going to have to include all the parts of the standard apparatus. So you're going to have to write ring stand, blah, 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 all that good stuff. Okay, so you got to talk about all those things that you need. Does that make sense? Okay. You can also assume that the person can light a Bunsen burner. So Anthony doesn't have to say, okay, first plug it into door number 1. Okay, it's really a valve, but we call it door number 1 here. And then you want to make sure door number 2, like, you can just say, light the Bunsen burner. Because you're assuming they know how to do that and get a perfect flame. Does that make sense? Okay. But you will need to include Bunsen burner and striker in your materials list because they need to know everything they got to get out. Okie dokie. Now, here's a question for you. When do I stop? That's a great question. So here's some things that you need to do. You need to figure out what's happening when the water is boiling, right? Well, now Riley, we're absent today, and then she's reading Sophia's procedure on Friday. She's like, wait, take the temperature every minute till when? Like forever? That sounds like it sucks. So you need to have something in there like, take temperature every 2 minutes until water starts to boil, then take it every minute for 5 minutes. Or something like that, because that way they'll know, okay, I'll take temperature for 5 minutes after it's boiling, then I'm good. Does that kind of make sense? Okay. How often do I take the temperature, Mr. Pilcher? Yes. That's my answer. Yes. You choose. I don't know. You figure it out. Okay? So, yes, take the temperature. Here's your little data table. So you want to indicate your time. You want to say the units, though. So tell me seconds or minutes. Yes, ma'am?
So are we using this research question, but like creating our own, like how much water we use and
right.
Stuff?
How much water do I use? Yes. Which beaker do I use? Yes. Which graduated cylinder? Yes. You understand what I'm saying? Mm-hmm. Okay. Now, the hard part is getting your materials and procedure done. You can ask me for feedback after you worked on it for a little while. I'll give you tips here, like, oh, don't forget about this, or how am I going to know when that kind of thing. You got to imagine this is someone who's absent today and they're reading it, and they shouldn't have to ask you any questions. Does that make sense? The hard part is getting all this done. Once you get all this done, though, the back page is easy. So you're going to get to the back page. You're going to flip that thing over. Your procedure materials should be identical on the back page, except one change you're going to make on purpose. Okay? So here are the 3 questions that you guys can choose to check out. Okay? So maybe Ryan and co, they're just going to change the volume of the liquid that they use. So maybe you guys start with 200 milliliters and then you go down to 100 milliliters for trial 2. And everything else is exactly the same. We just change the volume. Okay? And then maybe Emerson's like, what if I add some salt? Here is 10 grams of salt. You'll be able to measure the exact amount, okay? So you want to do it in grams. Do not do more than 10 grams. So 10 grams is the max. If you want to just do like 2, that's fine. But this is the max, okay? So I'll just put 10 G max. And then maybe Grace and Glory, they're like, oh, we're going to go with a different initial temperature. So that means you definitely want to get the initial temperature of your water at 0 minutes for your first one. And for your second one, you may have to put in your procedure, use hot water tap. Make sure you record the actual temperature, but just go for the hot water tap to get something that's a little bit warmer. Does that kind of make sense? Okay. But everything on the front and back should be identical, except for your one change.